but still I am waiting for uploading. Is it my voice is clear? Last session in last week, I have an introducing about the references and sources we use in this course, and also I will send you on the WhatsApp group as soon possible. Okay, seismology, earthquake effects. Last session in last week, I had descriptions and explanations about the earthquake and definitions about the earthquake. Earthquake defined and maybe simply described as a sudden shaking phenomenon of the earth's surface due to disturbance inside the earth, and in the classification classified in two groups, First, tectonic earthquakes. Second, nanotectonic earthquakes. Tectonic earthquake, in fact, due to disturbances or adjustments of geological formations taking place in the Earth's interior, in that's coming from the inside Earth due to a slope aligned geological faults, less frequent, more intensive, more destructive in nature. This type of earthquakes, tectonic earthquakes. Tectonic earthquakes due to external or superficial cases such as volcanic eruptions, huge waterfalls, occurrence of sudden and major landslides, man-made explosions, impounding in dams and receivers, or collapse of caves, tunnels, etc. Very frequent, minor in intensity, generally not destructive in nature, in comprised with tectonic earthquakes. We have some parameters in earthquake terminology as seismograms, focus of hypocenter, epicenter, focal depth or focus depth, hypocentral distance, epicentral distance is a seismal lines of equal seismic intensity, and co-seismal lines designating the affect area. I have talked and described about these parameters as earthquake terminology. This in this slide again as a review shows our reference and sources we use in this course. Some scope of presentations in this course and a definition of earthquake and classification I had talked before, and also I had talked about the types of earthquake of two types, tectonics earthquakes and nanotectonic earthquakes. Also as earthquake terminology I had talked before and described, and in this slide shows the parameters of an earthquake as earthquake terminology. Shows focus of hypocenter, focal depth, hypocentral distance, and maybe that site give distraction as shows in this schematic shape. Also, you can see the epicentral distance and epicenter on the ground. The focus of our hypocenter, in fact, is the point of the distributed earthquake on the depth of ground and start the vibration with some waves and coming on the ground surface. And the distance between epicenter and focus of earthquake called focal depth. And in the vertical axis. And the distance between the epicenter and the site called epicentral distance in horizontal axis. Also, you can see hypocentral distance between horizontal and vertical axis. Between site and focus or hypocenter as schematic shapes in this slide. And seismology is science dealing with all aspects of earthquake in type of observational seismology and engineering seismology. In seismology include recording earthquake in microseismology, cataloging earthquakes, observing earthquakes effects on macroseismology. And another type, seismology dealing include engineering seismology. In engineering seismology, in fact, is estimations of seismic hazard and risk, also seismic buildings. Also, we have in another type, physical seismology. The physical seismology is a branch of seismology that include study of the properties of the Earth's interior, study of physical characteristics of seismic sources. Also, I talk about what happened during an earthquake. During earthquake, the energy is realized in the form of waves and radiates in all direction from a source, the focus, as you can see in next slide. You can see the schematic shapes. In these schematic shapes shows the block of the earth, and that shows the focus of earthquake in the point of under surface ground that distributed the energy from focus point and then distributed with the waves in front of between the false block and coming the surface ground and distributed on the surface. This energy or vibrations with the waves and give distractions in structures or the surface ground. The earthquake waves that distributed the energy, earthquake energy, and included and classified two types as body waves and surface wave. The body wave earthquakes included P wave, S wave, and L wave, as you can see in this slide. P wave, also called primary wave or longitudinal waves, and maybe sometimes uh, called the primary waves. That has a speed around 8 to 30 kilometer per second to distribute the earthquake released energy. In the P wave or primary wave, in fact, the direction of motion of particles is the same axis the wave distribution. S wave is another body waves or called shear waves or transverse wave that has the speed between 5 to 7 kilometers per second. In the S wave, as one of body wave, in fact, a shake motion at a right angle to their direction of travel that change the shape of the material, transforming them in the shear waves. Can travel only through solids, but and as differences between P wave and S wave is the velocity and the direction distributions, and also that material can distribute or moving. The P wave can distribute in the all material, solid, gases, and liquid, but the S wave can distribute during the solid materials. Also, the S wave has the velocity slower than P wave, a slightly greater amplitude than P waves and laser amplitude than L wave. Also, the direction of distributions, the S wave is on the vertical axis of the motion of vertical motion or motion of particles of materials distributions. You can see the distributions of the P wave and S wave in the chromatic shapes. Another type of seismic waves called surface waves travel along outer part surface of the Earth, and they had has case greatest destructions and exhibit greatest amplitude and slowest velocity of body waves. Also, in the surface wave, the wave have the greatest periods in the time travel between crests, layer of Earth, often referred to as line wave or L wave, is also shows in this slide. How are earthquakes located, and how can find the locations of or focus of earthquakes? The sensitive instrument called seismograph around the world record the earthquakes event. Seismograph, in fact, record seismic waves belong the earthquake event. The schematic shapes of one of the seismograph shows in these schematic shapes. The seismographs record the movement of Earth in the relation to a stationary mass on a rotation drum or magnetic tap. You can see the instruments of a seismograph's equipments. In the tail of seismograph, we have a spring hang, suspended mass, rotating drum, and armchair base. That's shows in these schematic shapes. More than one type of seismograph is needed to record both vertical and horizontal ground motion, and uh, in fact, actually use 3 seismograph for record the seismograph seismograms at minimum. Also, you can see the graph that's record with a seismogram, the showing P and S and L wave as for example. For finding the location of the earthquakes, we need 3 station recording to find location of epicenter and focus of the earthquake. Each station determines the time interval between the arrival of the first P wave and the first S wave at their location. You can see the seismographs in travel time graphs that used to determine each station's distance to the epicenter with PS interval per distance to epicenter in kilometers. Also, the curve shows the difference in arrival of the P and S waves. A circle with a radius equal to the distance to the epicenter drawn around each station. The point where all three circles intersect is the earthquake epicenter. This method, called triangulations, that use three station recording. Another parameters we have defined as before, that was magnitude of earthquake, that related to the amount of energy released by the geological rupture, and that energy released in during an earthquake. Measure of the absolute site of the earthquake without reference to distance from the epicenters. We have two types to measure the magnitude from the scientists, Richter or Mercalli scientists. Richter in 1958 defined the magnitude as the logarithm to the base 10 of the largest displacement of the standard seismograph situated 100 kilometers from the focus. The largest magnitude of earthquake recorded in equal 8.9, as you can show the equation for the magnitude, for measure the magnitude of earthquake in this slide. That is logarithm A base 10 equal 4.8 plus 1.5 m. In this equation, E is energy per joules and m is magnitude. Another, the measuring for magnitude of earthquake and intensity of earthquake come from the Mercalli. The intensity, in fact, is a measure of the degree of earthquake shaking at given local based on the moment and the amount of damage. In this table, that shows the modified Mercalli intensity scale that's divided the intensity of earthquake in the 12 scale. As you can see the table. The drawback of the intensity scales is that destructions may not be a true measure of the earthquake actual severity. That measure in this in H intensity scales per the intensity of humans and maybe structures and anything can give destruction a maybe felt of the intensity of earthquakes. In level 1, no felt by anyone, by just very few under especially favorable circumstances can felt so few. According and that's I explained before, the magnitude is and in fact estimates the amount of energy lies at the source of the earthquakes. And for example, this table shows the earthquake magnitude and energy equivalence uh, per energy lies millions of earth and shows the approximate energy equivalence. In columns 1 show the earthquake magnetic between 10 scales, and in columns 2 shows the energy realized per uh, millions of ergs energy. Also in columns 3 shows the approximate approximate the energy equivalence. You can see, for example, the in the earthquake magnitude estimations equivalence energy. This table comes from the source US Geological Survey. Also, in next table shows the Richard magnitude scales and per effects near epicenter, also estimated number per year give the destructions. In fact, the Richard scale based on the amplitude of the largest seismic waves recorded. And accounts for the decrease in wave amplitude with increased distance. Each unit of Richter magnitude increase corresponds to the tenfold increase logarithmic scale. The distractions from a seismic vibration that distributed with the waves can include ground shaking, liquefaction of the ground, such as tsunami or seismic sea waves, and landslide and ground subsidence or fires. Amount of structure damage attributable to the earthquake vibrations depends on proximity to populated area, magnitude, intensity, and durations of the vibrations, nature of the material upon which the structure rests, design of the structure. Sorry. Also, we have the descriptions, age of destructions between enduring the seismic vibration. First one, ground shaking can occurring during the seismic vibration. In fact, the ground vibrations actually the regions within 20 to 50 kilometers of the epicenter will experience about some intensity of ground shaking, destruction, or destruction varies considerably, mainly due to the nature of the ground on which the structure area built. Can give damage, breeze can give the damage on the structure and give destruction in the some structures. Another destruction from seismic vibration is liquefaction of the ground. The liquefaction of the ground can occurring on consolidated material saturated with water, turn into a mobile fluids, also can cause underground structure to migrate to the surface and buildings and above, other above ground structure to settle and collapse and give the rupture, collapse, and failure in the structures underground after liquefactions of the ground enduring the seismic vibration. Another earthquake destruction can occur during the seismic vibration is sieges. The teaches, in fact, actually the rhythmic sloshing of the water in lakes, receivers, and enclosed basins. During sieges, waves can weaken receivers' walls and cause destructions. Another earthquake destruction is tsunamis or seismic sea waves. That's come give the water waves and surge waves and give destructions in seaside uh, structures or grounds. Another is landslide and ground subsidence that's occurring during the earthquake destruction in cases seismic vibration. Another distraction is fire, and then no needs more explanations and description that ground the movement or failures the ground and give the motions the soil failures on the some slopes surface and give distractions in the surface slope, and then according the instability in the some slopes ground. Also, I want to introduce to earthquake geotechnical engineering and its practice, and give you some information about the earthquake geotechnical engineering and its practice. I should change the slide and let me some second to change this slide for upload the new slide and give you more description and explain about earthquake as earthquake geotechnical engineering and some distractions that occurring with the geotechnical earthquake geotechnical earth geotechnical properties of earth. First, I am talking about earthquake hazard related to geotechnical engineering. What hazard and destruction may be occurring in during earthquakes? As before described about this hazard and that's destruction that's occurring during the earthquake, I have to explain about that. First, ground shaking, liquefaction, landslide, retaining structure failure, fire, tsunamis can occurring in during and earthquake with seismic vibrations cases. The fire is indirect result of earthquake triggered by broken gas and power line, or maybe tsunami. In fact, is the large waves created by the instantaneous displacement of the seafloor during submarine faults. And as definition, ground shaking, the ground shaking is shakes a structure constructed of ground casing, then the collapse and liquefaction, conversions of formally stable cosyneless source to fluid mass casing damage to the structure. And the retaining structure failure occurring, in fact, damage of anchored wall, sheet pile, other retaining walls, and sea walls. Earthquakes have varied effects, including change in geological failure, damage to man-made structure, and impact on human and animal life can affect in the human and on human and animal life, also can damage to man-made structures, also can occur uh, from geological features. Earthquake damage depend on many factors. Some of the factors in related earthquake damage are: first, the size of the earthquake so important in the damage and destruction that's occurring during the seismic vibrations distribution. Another factors in related earthquake damage is the distance from the focus of the earthquakes. Another one is the properties of the material at the site. If the material properties, so more strength and more stiffness, give less destruction and damage in the site material. Another factors for earthquake damage is the nature of structures in the area, as the buildings, bridge, roads, or airfields. Uh, the nature of the structure is the so important. The ground shaking frequency of shaking differs for different seismic wave. High frequency body wave shakes low buildings more. Low frequency surface waves shakes high buildings more. And the ground shaking is intensity of shaking also depends on type of subsurface material. In fact, unconsolidated material amplify shaking more than rocks do. Building also buildings respond differently to shaking depending on the construction styles, materials such as wood, more flexible, holds up well, and earthen materials, reinforced concrete, very vulnerable of shaking. You can see in these pictures the collapse of buildings enduring an earthquake. Occurring these destructions with the vibration seismic cases. That's collapse and breaks in the structure, buildings structure. Also, you can see in this picture the crackings or failure in the first story. The first story that's made of soft material, less strength and soft material and less stiffness, and no flexible material. This picture come from Loma Prieta earthquake damage in San Francisco. You can see the soft first story is due to the construction of garages in the first story and result reduction in shear strength in this slide. Another slide shows the failure of bridge abutment. Foundation and columns of the dwelling at the long beam shaped hill that's come from Kashmir in 2005, according the earthquake 2005 in the Kashmir, 8 October. That give the failure and collapse all the bridge enduring the seismic vibration and make the total collapse. Another slide shows the breaking and failure in the bridge base enduring the earthquake 2005 on Kashmir. in the suspension bridge in Walcott. Another slide is the picture from the one of destruction of in the buildings in during earthquake. The building overtraining and give destruction and made damage. Buildings that are not designed for earthquake load suffer more, and that's give the damage during the seismic vibration. Another picture shows the cases failure of lifelines in the railroads of trains after an earthquake. Another slide shows an earthquake distractions, land slides. Triggered by the vibration. Next slide shows an earthquake distraction enduring of distraction, in fact, liquefaction. When conversion of formally stable positionless soils to a fluid mass, causing damage to the structures in this the bridges, flow failure of structure caused by loss of strength of underlying soil. Next picture shows sand boils during the case of liquefaction in an earthquake. In fact, groundwater rushing to the surface due to liquefaction. And moving the sand look like the water motion. Lateral deformation and spreading. Next picture show lateral spreading in the liquefaction related phenomenon of the liquefaction on an earthquake during a seismic vibration. In these pictures shows schematic shape, liquefied zones before an earthquake and after occurring an earthquake. Before earthquake is safe and health, and after occurring liquefy in this zone, give the fault and crack. Lateral spreading in the soil bent embankment case the embankment to be pulled apart, producing the large crack down the center of the road, look like the fault, near the fault. That picture come from the Alaska Highway in 1964 during an earthquake causes seismic vibration. During lateral deformation and spreading, down a slow movement of soil when low sandy as liquefiable soil is present at slopes as gentle as 0.5. In situations where strength near or past liquefaction are less than the driving static shear stresses, the formation can be large and global instability often results. Next slide shows the pictures, the destruction during the liquefactions, and give some destruction on surface, ground surface near seasides and structures. Liquefied soil exerts higher pressure on retaining walls, which can cause them to toilet or slide, and give some distractions, failure in the ground surface and crack on the surface structure of ground near seaside after liquefaction. In this slide also shows in situation where a strength near or post liquefaction are less than the driving static shear stress, The formation can be large and global. Instability often results as same in the failure of the ground surface in this picture. Next slide that shows the collapse of dam in during the case of increased water pressure during the liquefaction. The down slope movement of soil when low sandy and also same liquefiable soil at a slope as gentle as 0.5 can occurring and give damage and collapse in the slopes as for example shown in this dam, soil dam. Another destruction occurring after earthquake in during seismic vibrations is fire. Earthquakes sometimes cause fire due to broken gas lines, contributing to the loss of life and economy. The destruction of lifelines and utilities make impossible for firefighters to reach fire's start and make the situation worse. In this slide, I show some few pictures from 1989 in during the and earthquakes in Loma Porotia, San Francisco in 1989, Loma Porotia, and 1906 San Francisco earthquakes. That's made fires in during and after earthquake. In cases broken, the gas line, maybe sometimes the whole lines, and etc. Another distraction in during, as that's described before, during the earthquake is tsunami. As shown in this picture, shows the tsunami movement in depth and with velocity 600 miles per hour in depth water and maybe around 250 miles per hour in the medium depth water and 35 miles per hour in shallow water as shown in this schematic shape. Tsunami, as shows in this slide, can be generated when the sea floor abruptly deforms and vertically displaces the overlying water. The water above the deformed area is displaced from its equilibrium position. Waves are formed as the displaced water mass, which acts under the influence of gravity, attempts to regain its equilibrium. Tsunami travels at a speed that is related to the water depth, hence as the water depth decreases, the tsunami slows. The tsunami's energy flux, which is independent of the both its wave speed and wave height, remains nearly constant. Consequently, as the tsunami's speed dimensions as it travels into shallower water, its high grows because of this effect as tsunami imperceptible at sea may grow to be several meters or more in height. As you can see, the tsunami movement during the earthquakes that generated when the sea floor abruptly deforms and vertically displaces the overlying water. Next slide shows the tsunami of 3 meter high at Chickton in Career Island, 1994, carried this vessel 70 meters on shore near seaside. The wave have eroded the soil and deposit debris. That's generated when the seafloor abruptly deform and vertically displays the overlying water. The water above the deformed area is displaced from its equilibrium position and waves are formed as displaced water mass which acts under influence of gravity attempts to regain its equilibrium. Next slide that's describe about geomorphological change of enduring earthquake and after earthquake. Geological change are often caused by an earthquake, for example, movement either vertical or horizontal along geological fault traces, the rising, lowering, and tiling of the ground surface with related effects on the flow of groundwater. An earthquake an earthquake produces a permanent displacement across the fault. When a fault has been produced, it is weakness within the rock and it is the likely location for future earthquakes. After many earthquakes, the total displacement on a large fault may build up to many kilometers and the length of the fault may be propagate for hundreds of kilometers. Ground improvement for liquefaction, hazard mitigation. Ground improvement. One of the way to improvement the ground and soil to decrease the liquefaction is ground improvement techniques. During the ground improvement in poor and weak subsoil, the design of conventional shallow foundation for structure and equipment may be present problems with respect to both sizing of foundation as well as control of foundation settlements. Traditionally used pile foundation and have been employed often at enormous costs, a more viable alternative in certain solutions. Developed over the recent years is to improve the subsoil itself to an extent such that the subsoil improvement would have resultant settlements within acceptable limits. The techniques for ground improvement has developed rapidly and has found large-scale applications in industrial projects. Is some description and explanations about ground improvement technique that use for poor and weak subsoil in the surface to improve the soil before the built structure under the foundation. Okay, then ground improvement. Ground improvement is indicated if net loading intensity of the foundation exceeds that allowable bearing capacity pressure, or the resultant settlement or differential settlement exceed acceptable limits for the structure, or that used when the subsoil is prone to liquefaction in seismic events. In these three types of cases, use the green improvement for the increase the strength and bearing capacity of soil. When net loading intensity of the foundation exceeds the allowable bearing pressure or uh, resultant settlement or differential settlement exceeds acceptable limits for the structure, or the subsoil is prone to liquefaction in seismic event. We have 5 types of ground improvement by function. These 5 types of ground improvement shows in this slide. First one is excavation, field placement, groundwater table lowering case. Next one is the second type for ground improvement is densification through vibration or compaction. Third, we can use drainage through dissipation of excess for water pressure. In fourth type, we can give more resistant rock inclusion. And fifth, we can use stiffening material through cement or chemical addition as additive material. Next slide. Next slide shows the table for the according the suitable soil type and the case of type of the soil for densification through vibration and compaction. Vibrating probe vibration or vibro fluctuations. Vibration case again structure to collapse, densifying soil rises and lower in the grade pattern that's shown in this table in this slide. In column 1 of the table, show the type of suitable soils for densifications, and second column show the depth of saturated or dry or clean of sand that shows, and the cases for densification, and also if in this soil improvement type that's called densifications through vibration and compaction, most suitable soil type is saturated or dry clean sand we can use for densifications. And maximum effect treatment depth is 20 meter in effective in upper 3 to 4 meter. A special material required, no need any special material for densifications for soil improvement. A special equipment required for this type of soil improvement is laboratory pile driver or Viber float equipment. Can in fact treat the material of soil around the relative density equal 800%. That show with dr equal 800% relative density. A special advantage and liquefaction in this technique is first, this technique is rapid, simple, cheaper than stone columns, compaction pile, and less effective than methods that employ compaction as well as vibration. Also, difficult to penetrate stave over layers, may be ineffective for layered systems. And about the relative cost is moderate and no more expensive, no more so cheap. But this method is cheaper than a stone column and also rapid method for soil improvement. Another method for densification of soils, soft soil, is vibro compaction, replacement stones and columns. The properties of this method shows in this slide in this table. A steel casing drawing to the soil, gravel or sand is filled from the top and tempered with a drop hammer as the steel casing is successfully withdrawn, displacing the soil. As the properties of this method, the most suitable soil types in this method is cushionless soil with less than 20% fines. Also, the maximum effect treatment depth in this method is in the maximum 30 meters. And the special material required in this method is granular backfill, and a special equipment required in this method is vibro fold equipment, steel casing, hopper for backfill. In this method can obtain high relative density in related and in differential between others method. A special advantage and limitations of this method is This method is rapid and so fast. Also, in this method is useful for a wide range of soil types and may require a large volume of backfill noisy. Also, as the limitations of these methods, an advantage is many require a large volume of backfill. Also, this method is so noisy and some causing problem for neighbor of buildings. And how about the cost? The cost of this method is moderate, no so high, no so less, no so expensive, no so cheap. That's depend of the area of the improvement that the cost is moderate. Another method for soil improvement called dynamic densification or heavy temping, using heavy detemping. In this method, a heavy weight is dropped in great pattern for several passes. The properties of this method shows in this slide with this table. The dynamic densification method using heavy tamping most suitable for cushion-less soil, waste fields, partly saturated soils, and soils with fine can most suitable. Maximum effective treatment depth in dynamic densification method is around 30 meters, less at the surface. Degree of improvement usually decrease with the depth. No special material required needed for dynamic densification method. The material used for treatment, the properties of treatment material is good improvement and reasonable uniformity. Also, a special advantage and limitations of dynamic densification method. This method, so rapid, simple, may be suitable for soil with fines. As limitations in this method can describe a lack of uniformity with depth, not possible near existing structure because so noising and maybe so give a problem for neighbor and adjustment structure. Maybe granular backfill surface layer. The about the cost so low and cheap for independent of the depth of densification, the cost so low, and for large area that is so useful and many benefit. And about other methods for soil improvement can defined as displacement piles, use compaction, growthing, or use displacement piles. In during displacement piles, the in this method, densification by displacement of pile volume usually precals concrete or timer pile using for uh, densify the soil. In the compaction growthing, use densification by displacement of growth volume. That shows in this slide. In next slide, show the stiffing draw cement or chemical additions, the permission of penetration growthing that show high permeability growth is injected into the growth at numerous points result in solidified soil mass and show the properties of using the cement or chemical addition for soil improvement in the table in this slide, or that's called soil stabilizations. In the soil stabilization by cement or chemical addition, the most suitable soil type in this method is saturated medium to coarse sand. We can use for this method soil stabilization with cement or chemical addition for usually medium to saturated medium to coarse sand can use, and maximum effective treatment depth for in the during the cement or chemical addition soil stabilization is 30 meters. A special material required for this method is growth of cement mixed with cement or chemical addition, maybe lime, maybe bentonite can use. Properties of as a properties of treatment material can uh, defined as impervious high strength where completely mixed material with cement or chemical addition as additive soil stabilizations. A special advantage in the soil stabilization with cement and chemical additive are first produces a hard, stiff mass of soil and useful for existing structure, as it causes little or no settlement or disturbance, low noises. As disadvantage and limitation are area for cremation can vary, can be blocked by pockets of soil with fines, difficult to determine to the improved area, and can uh, has limitations, require curing time, needed more time and past time for every step by step, and it take time for curing time in duration. The growing, the growing can give hardness and stiffness around 90%, duration 1 week or 7 days. In 90% strength. At relative cost, this method least expensive of grow system, but moderately expensive compared to fiber row method. Earthquake resistance designs of geotechnical structure. For earthquake resistant design of geotechnical structure, can use some geotechnical structure like retaining wall, sheet pile, a slope or shallow foundation, deep foundation, can use for more strength, uh, soil strength, and designing more resistant and more strength structure. Must be designed to with a standard stand earthquake loading, and use this geotechnical structure in the stiff and the less strength area. This was some view about the geotechnical structure and technical techniques for soil improvement and more strength, designing in the during the an earthquake for less destruction and more strength, and decrease the earthquake energy. Okay, Any questions? If you have any question, you can ask and give you more explain about that I have talked before in these sessions. Please, you can ask. I am so sorry. I think the time is over and we can continue next week about this course and some of definitions and explanations and phenomena about the seismology in the next week. Thank you very much. Okay, thank you very much. See you next week. Goodbye and have a safe and health time. Goodbye.